All right, so let's say we want to do a hypothesis test for a correlation. Step 1, as with any other hypothesis test, we're going to write our hypotheses. And here we're in 3. And we'll say for these that we also have an alpha level of 0.05. Your null hypothesis is that there is no relationship between two variables. And for this example, I'm going to use the siblings and tattoos. So our null hypothesis is that there is no relationship between the number of siblings and the number of tattoos that people have. And here we're going to be treating the class as a sample again, so we'll be thinking about whether there's a relationship between siblings and tattoos among criminal justice students as a whole at Rutgers. Our alternative hypothesis is that there is a relationship between these two variables. So our alternative hypothesis is that there is a relationship between number of siblings and the number of tattoos. That people have. Another way to write these is like this. And this can save your hand a little time. Your null hypothesis is that the correlation between two variables is equal to 0. So there is no relationship between the number of tattoos and the number of siblings that people have. In other words, the correlation between tattoos and siblings is equal to 0. Your alternative hypothesis then is that there is some relationship between those two things, and that means that your correlation, or R value here, is going to be something other than 0. So with this hypothesis test, what we're really looking at is whether this R value is statistically different from 0. So whether we have evidence based on our sample that the correlation value for these two variables in the population is something other than 0. And as a quick note, the slide says association, this says relationship. They mean the same thing in this context, so either one would be fine. All right, step 2. We're looking at a test statistic. And here, as I mentioned, your test statistic is actually going to be the R value. So there's nothing to calculate at all. We're just going to be looking at that R value that we have. And the test statistic is equal to R. So obviously this is something that can be calculated, but we're going to leave it to a computer to do that. As with other hypothesis tests, the R value that you get gets plotted on a sampling distribution where we have possible R values, the probability of getting each one, and our sample R value will fall somewhere on that distribution. So at some point, our sample R value is big enough that we'll conclude that it probably came from a population where R isn't equal to 0. So again, this is if your null hypothesis is true. If the correlation between two variables really is 0, how likely is it you would have gotten the sample correlation that you did? And depending on how much bigger than 0 your sample correlation is, you'll get a p-value that's equal to some number, and we'll be using that to decide whether to reject the null hypothesis. So a bigger sample R value is less likely to have come from a population where the true value is 0, and so the smaller a p-value you'll have. And our final step here is to decide whether to reject the null hypothesis. We're going to do it the same way that we did for every other hypothesis test, which I think is one of the reasons that hypothesis testing is a great unit, because it's like once you get it once, you're probably good to go. So here we're going to be looking at the p-value that we have for a particular sample value. As I said before, the R value for siblings and tattoos is equal to 0.099. And the p-value that we're going to get for this is equal to 0.56. So I have this on a computer program, again, and it's coming up with a p-value based on the R value that we have and the sample size. So here we have a p-value of 0.56. We're going to compare our p-value to our alpha level. Sorry, p-value to our alpha level. And here we see that our p-value is much larger than our alpha level. So in this case, we're saying that if it's true that the number of siblings and the number of tattoos that people have is not related in the population, so if it's true that R is equal to 0, we would see a test statistic as large as R equals 0.099 about 56% of the time, just by chance. So totally by chance, we'd see a correlation as big as the one that we did 56% of the time if the null hypothesis were true. And this means that we fail to reject the null hypothesis. So in other words, our sample correlation of 0.099 is not big enough to give us evidence that the correlation between these two variables in the population is anything other than 0. So we fail to reject our null hypothesis that this is equal to 0, because this correlation that we saw would occur about 56% of the time if the true population value was equal to 0, just by chance.